Hey everyone, we're actually going to continue with our differentiation techniques. Well, so far we've looked at trigonometry, we look at algebra, and now we look at something that is slightly easier, alright? Exponential. So we have y equals to e power of x, and then y equals to a power of x, where a is bigger than 0. Okay. The formula, alright, is actually very different from the power rule. So you might think that, there are some similarities between this and the power rule of y equals x power of n, and therefore the derivative is bring the n down, then reduce the power by 1. And you might think that, well, apply the same logic, right? dy dx would be x e to the power of x minus 1. Well, no. Alright, the difference is that the power of e is a variable, whereas in x to the power of n, the power is a constant. And that makes a whole lot of difference, alright? So basically, y equals e power of x, the derivative, actually, like this, alright? First, we put back the original function, ex. Then, we differentiate the power. So x differentiated is 1, so yeah, 1 times ex. For a to the power of x, same thing, dy dx. Keep the same function, a to the power of x, differentiate inside x. The only difference from e is that you must times a ln a. And there we have it. Dy dx equals to a to the power of x times ln a, where y equals to ax. This is actually the general form of exponential differentiation. Alright? Let me look at more examples. So let's say y equals to e power of x squared, y equals to a power of x squared. Same thing, dy dx. Copy down the original function. Then you times by the derivative of the power. So x squared, the derivative will be 2x, so you times 2x, and therefore we have 2x ex squared. Same thing for here, only is that you have times ln a. So ax squared times 2x ln a. We therefore have 2x ln a times ax squared. And we're able to arrive to this general formula. So we have y equals to a to the power of fx. The derivative would then be f prime x times ln a times afx. And this is how we differentiate exponential at a to the power of x.